So now that we've matched these, check out your standard form. Your standard form is nice because I already know that my vertex is 2, 7. I know that it's negative so that it opens down. And because it's a 1, I know it follows the 1, 3, 5. Dentist class is really loud. The second one, I know that my vertex is at -2, -1, and I know that it opens down because of the negative, and it follows the 1, 3, 5. The third one, I know that my vertex is at -1, -4, and I know that it opens up, and because of the 3 in front, instead of the 1, 3, 5, it would have 3, 9, 15. And the last one, I know that my vertex is at 2, 5, and the 3 means it's positive, it opens up, and it also follows the 3, 9, 15, because it's been stretched vertically to make it narrower. Look at your general form. I can't get the dentist imagery. It's out of my head. I sure hope that person is sedated. In the general form, can you tell that the vertex is not easy to see? There's nothing in the purple one that's like, oh, definitely -1, -4. I see it right now. You do not see the -1, -4. Can you see that you still see the up? And you still see the narrower because the A value stayed the same. But you don't get your vertex. So if I said, looking at the orange one, if I said graph y equals 3x squared minus 12x plus 17, we would currently be stuck. We would know that our parabola opens up. We would know that it's been stretched vertically, so it's narrower because of the 3. But you wouldn't know where to put your vertex in order to go over 1, up 3, over 1, up 9, over 1, up 15. You wouldn't know where your axis of symmetry is. So you could either just plug in a bunch of points and figure it out, or if we had a way to take the orange form on the right and switch it to the orange form on the left, that's going to be helpful. And that's what this lesson is about. Okay? So we have, first of all, I want to highlight a few things here. Right? We have standard form. Maybe I just want to highlight standard form and general form. General form doesn't help us graph very much. Okay? Standard form does. And what we're going to do is we are going to learn a technique to do this. Okay? No, and we're not going to use that. So we'll go to example 1. We're going to call this technique changing to standard form. That seems like a good title for the technique, right? Because you want to change it to the vertex form or the standard form. That is going to be the title for this. And you're going to notice some similarities to something you did in the past. But I'm not going to tell you what that thing is that you did in the past. But I want to see if you can see what those similarities are. So what happens here is if we want to take y equals 3x squared minus 12x plus 7, and we want to write it in the standard form, which looks like this. And the first pattern I hope you noticed was that the a value is the same in the general form or in the standard form. But in the standard form, the a value is factored out. Then there's something squared. Then there's a number all by itself. So what do I have right now? I do not have an a value factored out. I do have a number by itself, so that's maybe nice. What I'm going to do, step one, okay, and when we factor out a, we only have to do it out of the first two terms. Because we know we want a number at the end, so I'm going to leave the plus 7. It's probably going to be part of Q anyways. Now, do you know that I left a space here and a space? I'm going to leave a space there and a space there. Why? Because step 2, we need to write the x minus p squared part. So this is what we need to write. What's our hint? This part right here has to change to this part right there. The 4, the minus 4x is our hint. What has to be in here to make sure that when we square this, we would get a minus 4x? You would need a minus 2. So I just figured out this minus 2. I'm going to write it in blue because that minus 2 is going to affect what we have in that first space. What would have to be in this first space in order for that to be a minus 2? A plus 4. Now, you're not allowed to just add 4 to one side of an equation. It would make it unequal. In this method, in changing to standard form, I add 4 on one side, and then on the same side, I'm going to do something to make sure that I undo what I did. So by adding 4 on this side, it's made it heavier. Does it make sense that, I mean, in an easy way of saying, if you add 4 and subtract 4, you've basically added nothing. Okay? Anybody know why, if I add 4, I actually have to subtract more to make it equal? Subtracting 4 is not enough. How much would I have to, by adding 4 right there, how much would I have to subtract here to make it balanced?
12.
12. Why 12? Like 4 and 12, they're not the same.
Because you're multiplying the 4 by the 4.
Oh, you're multiplying. You see that this 4 is also going to get multiplied by that 3. So by adding 4 in the brackets, you're actually adding 12 to that side. Right? So you'd have to subtract 12. Normally, adding 4 and subtracting 12 don't equal up. I give you $4, you give me $12 back. You're like, no. No. But if I gave you 4 3 times, it would seem fair that you should give me $12. Right? So we have to realize that when we add the 4 there, we have to subtract 12. That makes 7 minus 12 a minus 5 here. And you see we have just changed it to standard form. We now know the vertex is 2, negative 5. What else do they want us to find? That's it! So exciting. I love when I reread the question and we've done what we were supposed to do. It just asked us to find the vertex, so we had to use the technique of changing it to standard form. What does this remind you of? When did we do something similar to this. It was different, but it's very similar. You remember? No? Never seen anything like this before? This technique? Completing the square. Okay? But you see it's a little bit different than completing the square? Okay? Some teachers actually call this completing the square as the method, but I don't like to do that because the methods are a little bit different, and then you get confused. So we're going to use completing the square as a method for solving, and we'll leave the words completing the square for that technique. And we're going to call this technique changing to vertex form or changing to standard form because it's a little bit different. What happened? You never had to factor out in the completing the square method. Instead of factoring out, you divided. Right? Remember, we divided if there was a number in front to get rid of it. Then in the completing the square method, you always did things on opposite sides of your equation. If you added 4 on one side, you added 4 on the other. And it was always the same because we had divided. This one's different. When we make the spaces, they're on the same side. And one number might be different than the other number because of the value of A. Okay, so we're going to end there. And I'm going to give you the rest of the class to work on either the questions from 4.4 or these ones from 4.5.